Hello, this is Dr. Springer, and I'm going to be talking through now paper number 12, which was the calculator paper from June 2013. The first question here, you're presented with a formula and you're given some numbers which you're going to need to substitute in. So these numbers here are going to be plugged into this formula, and in this first case you're going to try and work out the cost of repairing the car with these three numbers here. So I'm going to rewrite this equation here, substituting for each of the letters. So I have that C equals N times L plus 1.2 lots of P. Now writing these numbers next to each other means they're being multiplied together in the same way the letters next to each other means they're being multiplied. The brackets just keep them separate so that it's clear that I'm multiplying 3 and 18 rather than writing 3, 1, 8. You could have just as easily written the multiplication signs in between these two numbers. We now evaluate this. Really important that these multiplications happen before the addition because of order of operations, because of BIDMAS or BODMAS, depending on what age you are. And so let's calculate this. So 3 lots of 18 is going to give me 54. 1.2 times 110 will be 132. You do have a calculator in this exam, so make sure you do use it if you're at all unsure about your arithmetic. And that gives me a final answer of 186, so my answer is 186. All the numbers I plugged in were in pounds, so I get an answer out which is in pounds as well. The second part of this question is asking me to fill in a missing value in the table. So this time I'm being told the cost, I'm sort of being told the answer to this formula, and then I'm being asked to work out what the missing number n is here. So I'm going to write out this formula and I'm going to fill in all the numbers I know. So I'm going to get the cost 235 equals n times L. I'll just write this the other way around. I'll write it as L times n because I like to write numbers before letters when I'm writing algebra, plus 1.2 times P. That'll be 1.2 times 150, which will be 180. Yep. And now I need to solve this equation, so I'm going to try and get n by itself in this equation. So that means taking away 180 and then dividing by 22. So when I take away 180, my next line will be, let me just move this up a little bit, my next line will be 55 equals 22n, giving me that n equals 2.5. So I'll fill that back into the table here. The n must be 2.5. To check that works, you could go back and you could look at this original formula. You could plug in n is 2.5. You could plug in n is 2.5, L is 22, 1.2 is there, and the 150, and check that you do get a cost of 235. There's usually enough time in the exam to check your answers, so you could either do that at the end or make sure you've got this one right before you move on to the next question. This next question is about a scatter graph. I'm already given some data here. Before I even start this question, I need to make sure I understand what it's all about. It's telling me it shows the scores that 10 students got in their oral and written tests. This must have been some kind of language exam. Just trying to understand what one of the points means. For instance, this point here is telling me that there exists a person who got 50 in their oral test and a score of 34 in their written test. Okay, it looks to me like the better people do in their oral test, the better they do in their written test, because this line is going up. There's a kind of general trend which is positive. Okay, hopefully they'll ask me about that at some point later on in the question. The first question here is saying how many students scored 50 in their oral test. So if I look at where the mark of 50 is in the oral test and I go up and I see how many people got that mark, I see that there are two possible values. They scored different results in the written test, but they got the same oral test result. So my answer is that 2 people did. The next part of the question says that 4 more students are taking the same tests and you've got their scores here, and we need to transfer that information onto the diagram. So this first person scored 10 in the oral test and 15 in the written test. So 10 in the oral test and 15 in the written means I go to there. The next person got 94 in the oral test. They did very well in the oral test, and as we sort of expect from the other information, they also did very well in the written test. They got 90 in the written test. So I go to, that's way off, that one there's a bit better. Next one, 52 goes to 46, 52 goes up to 46. Being careful that on each axis the scale is that 1 little square is worth 2. I'm doing my best with this, but this stylus isn't particularly accurate, but make sure you're as precise as you can be. There's very little tolerance for this being wrong. The final one says that the oral score was 84, so that's going to be 80 plus 2 little squares more, going up to 80. So I go up and I get that I am I'm going to get there eventually. No, there, sort of. That's not ideal. But those points just seem to confirm the pattern I already spotted, which is higher oral marks means higher written marks, or vice versa, higher written marks means higher oral results. One important thing is we're not saying that one's causing the other, they just seem to be correlated. So, the next page, which I'm not going to scan onto because I need this graph, is it says draw a line of best fit on the scatter diagram. So, I need to now draw a line that sort of gives an idea of what this data is showing. So, it's going to be a straight line like this. Don't assume that lines of best fit have to go through 0. That's not unreasonable in this case. You would probably expect someone getting 0 in one test to maybe get 0 in the other. But here I'm just going to follow the line. I'd use a ruler to do this, and I'm going to go like that. Okay? So that is my line of best fit. Okay. The next question says that Rob scored 40 in the oral test, and it says he was absent for the written test. But they're going to try and estimate what he would have got in the written test based on this other information. So I know that he got 40 in the oral test, so I'll go to here. And in going up, I need to sort of decide how up do I need to go. How high a mark did he get in the written test? Well, using my line of best fit, it looks to me like I would expect him to have got a mark of about 40. So for 2 part D, I would expect him to get a mark of about 40. It's important that they will read off the answer based on what you've written down. So based on your line of best fit, provided it's reasonable, they'll mark you correct or incorrect based on your own line of best fit. They didn't actually in the end ask me about it, but it's important to note that this diagram here is showing me that oral and written tests are correlated. If it asked me to describe the correlation, I would say it was strong and positive. Okay, it's positive because as one goes up, the other one goes up, and I would say it's strong is because generally speaking, these points all lie very close to the line. The conclusion you could draw from that is that written and oral results are correlated. That means that they seem to be going up or down together. It's not making any kind of conclusion that one of them is causing the other one. In question 3, we're asked to analyse a survey. It says Andrew's planning a survey about his local library. He's presented us with a question and a response section which people should be filling in, and we're asked first of all to give one criticism of the question. So don't even look at these boxes for now, just look at the question and what might be a potential problem with that question. Well, if it asks how many times you go to the library, that's very much dependent on whether he's talking about in a week, in a month, in a day, and probably the best way of phrasing that is to say that there's no time frame given. It needs to specify how many times you go to the library in a week, in a month, in a year. So I would say no time frame given. Okay. You can elaborate and say, e.g., how many times do you go to the library per day or per year or per month or whatever. The second thing asked me to give 2 criticisms of the response section. So now I'm looking at whether these options he's provided are adequate. Okay. You always need to imagine that you're somebody who's incredibly awkward. You need to make sure that everybody is covered, so they have to fall into at least one of the categories, and you need to make sure that nobody falls into more than one of the categories. Now, in terms of a criticism here, the criticism really is 2 facets of the same problem. The problem here is that if you don't go to the library at all, you're not covered. So this doesn't cover all the options. It's also missing out people who go 4 times. Okay, so really, to my mind, that's the same criticism, but there's nothing else I can really find a fault. So I have to say that criticism 1 is that there is no option. There is no option for those who don't go to the library. So nobody's allowed to say 0 based on these answers who don't go to the library. And similarly, for criticism 2, there is, you could maybe turn it into the same kind of sentence, but there's no box for 4. There's no option for people who go 4 times. I'd have preferred, I mean, who am I to criticise this, but I would have preferred if the criticism had been that you didn't cover all the options because there's no option for 0 or 4, and that maybe they'd engineered it so they overlapped, so that maybe people fell into more than one category with a single answer. So the only 2 things you can really criticise within a response section, with the answer section, is anybody missed out? Is anybody unable to answer? And also, is there any confusion about where somebody should put their particular mark? And now this is question 4. Question 4 is showing us a kite. Just to talk about the properties of a kite. A kite is such that these 2 sides are the same length and that these 2 sides are the same length. It's not true that opposite sides are the same length. That's true for parallelograms rather than kites. But there are some other nice symmetry properties. I can straight away, without even thinking about this question, label on that this angle here must be 1, 4, 4 as well, because this angle and this angle are equal. The question is then asking me to work out the size of angle y. So I know that these four angles together must add up to 360. That's nothing specific about a kite, that's true for every quadrilateral. So I know that all those numbers add up. I'm getting 2 marks for this, so I'll maybe just take a second or two to write it out in a bit more detail. 52 plus 144 plus 144 plus y equals 360. Again, when they're marking this, be looking for some kind of suggestion that you know that adding up gives 360. What I've written there is a very clear statement of that. When I add these up, 144 plus 144 is going to give me 288. When I add on 52 to that, I'm saying this out loud, I'm not even doing it in my head, 288 and 52, I should be able to do that a lot quicker, that's going to give me 340. 340 plus y equals 360, y equals 20. So I'm just remembering I could have been using a calculator, so I didn't need the humiliation of failing to add up 3 numbers correctly. But in an exam, you're probably better using a calculator to make sure you are doing it correctly. And that is that. This next question is a sort of problem-solving question, a functional maths question. I'm alerted to the fact there's a star next to this, so I'm going to make sure that what I write down is very clearly laid out. If a couple of sentences help, so be it, but it's just really important that every step is made clear to the examiner. So before I go down and actually do this question, I'm going to leave it zoomed in because I'm noticing that Jenny is packing a box here full of cases. So it's going to be important to me in this question to know how many I've got. So let's have a look. I notice that I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 going up. I've got 1, 2 across the way. And I see that I've got 1, 2, 3 going across in this direction here. So in total, I know that this case here will contain 3 times 2 times 8 equals 48. So there are 48 cases. So now let's think about what the question's actually asking me to do. So it's saying she's buying those 48 cases for £2.43 and she's going to sell them on individually for 11 pence each. Okay, so let's work out how much money she'll make if she sells each of these 48 cases for 11 pence each. So what I'll do is I will do 48 times, now if I times by 11 I'll get an answer in pence, if I times by 0.11 I'll get an answer in pounds. I'm noticing that the question's eventually going to be in pounds, so I'll maybe keep it all in pounds now. I'll do 48 times 0.11. Again, you can use a calculator, but that's not too bad a sum because it's easy to work out 0.1, which is a tenth, and add on a hundredth as well. You get 5.28 pound. I'll just keep track of my units as I go. So she's already made a profit here. Okay, so she has spent £2.43 and she's made £5.28. So let's work out what she makes in profit. So her profit will be the difference between those. So I'm going to do £5.28 and I'm going to take away £2.43. Again, using a calculator along the way, I'll get £2.85. So that's her profit. So at this point, I've got down to this point here. I know the profit, and she's saving 2/3 of that, and that's what this question's interested in. Not how much profit does she make, but how much is she saving. So I need to work out 2/3 of £2.85. So I'll work out first of all 1/3. So 1/3. Let me just change to pen again. So 2.85. When I divide it by 3, will give me 1/3, and she's actually saving twice as much as that. So I'll then times by 2. 1/3 of that will be 95 pence, times by 2 will be £1.90. So I think at the end there that she should end up saving £1.90. Okay, I've just spent 5 minutes in this question trying to get rid of this line I've drawn. I don't know how, so just ignore it for now. It's not there. Okay, so work out the value of x in this question. So what am I told? I am told here that I've got a triangle. I'm given the length of each side, although it's terms of algebra, and I know that the perimeter is 48. Perimeter being the distance around the edge. So I'm going to set up an equation. I'm going to write down what the perimeter is in terms of algebra using these 3 values, and I'm going to set it equal to the answer that I know it is. So I'm going to have 2x plus 3x plus x plus 9 equals 48. Okay, so that's one of the sides, another one of the sides, and then the final side. The brackets here are just to make sure that the centimetres sort of apply to the whole thing. They don't need to be here. You don't need brackets if you're adding x and adding 9 as well. So let's now, before I solve this, collect it together. If you're going to solve an equation, always make sure both sides are as tidied up as they can be. So 2x plus 3x plus x gives me 6x. So I have 6x plus 9 equals 48. And this now becomes an equation to be solved. So I take away 9 from both sides and end up getting 6x equals 39, and then we're going to divide through by 6, and I'll end up getting x equals 39 divided by 6, which will be 6.5, 6.5. So x is 6.5 centimeters. Again, you could check this by going back up here and working out what each of these numbers actually is then. So 2 lots of 6.5 would be 13. 3 lots of 6.5 would be 19.5. X plus 9, that would be 9 more than this one here, which would be 15.5. And if you add those three numbers up, you're going to get 15.5 and 19.5 is going to give me 35. And when you add on 13, you do indeed get 48. Those numbers there were just part of me checking it. Get rid of that now. So question 7 is another functional maths question. I'm asked to compare the cost of two particular deals for owning a car for a year. I want to obviously work out at the end which one is cheaper, which one's going to cost me less. So maybe just so it's easy for me to refer to them, I'm going to call this deal A. This is the deal where I buy a car and then sell it on at the end of the year. And deal B is the one where I rent it. Now, there are two ways of going about this comparison. You could either compare after 1 year how much money you down, how much did it cost you after 1 year on this deal, and then again for this one here, work out after 1 year how much have you spent as well on this one, and then make a comparison. You could equally do it per month. Okay, so you could equally say, well, for each month, how much do I end up paying on this deal, and per month, how much do I end up paying on this deal. I just think it's easy to work over the entire year. It just means you've got a total at the end of it. It seems to make more sense to me. And if the question was slightly more complicated, if you're maybe dealing with something which had compound interest or something like that, it would be much harder to make a month-by-month comparison. So I think it's better just to see what situation you're in at the end of the year. So let's have a look at deal A. So deal A, how much is that going to cost me over 1 year? Well, I'm buying a car for £12,000, I'm selling it for £10,000 at the end, so I end up losing £2,000. It costs me £2,000. So I'm going to do 12,000, take away 10,000 equals 2,000. I end up spending £2,000 to own a car for 1 year on this deal here. Now let's look at deal B. Now, deal B, I'm paying a monthly fee. So over 12 months, I'll end up paying a total amount. Now, again, for this one here, you could work out how much would it cost to pay £195 for 12 months and then take the 15% off the end. But to me, it seems a bit more natural in this case that every month you're paying it with the 15% off. So I'm going to work out actually how much am I spending per month. I'm not actually giving them £195, I'm giving them 15% less. So let's calculate what that number there is. So I am given the original amount, 195, and I want it to go down by 15%. So I'm interested in 85%. A couple of different ways of doing that. I'm going to say this. I'm going to say that 100%, the original amount, is 195. I'm then going to go via 1%. This is the unitary method. And so the 85% that I want is going to be 195 over 100 times 85 gives me 165.75. The quick way of doing that is just to say I want to know what 85% is. So 85% of 195. You get the same answer of £165.75. I'm paying that per month. So over the whole year, I will end up paying 165.75 times 12 equals 1989. So that's by deal B. Again, you could have made it clear maybe here that this is per month. Oh, sorry, this is per month. And this is for the year. But now I need to make a very, very clear conclusion at the end. It's not just about you calculating two numbers. You need to say, well, which one is cheaper? Which one are you going to go for? And it seems to me that this deal is better. Deal B is better. Okay. Now, deal B is a label I've made up, so I'm going to go for renting it. I'm going to choose to rent, and I'm maybe even going to reason. I'm going to say because, and it's one of those kind of really trivial statements, but it's nice to just make absolutely sure, because 1,989 is less than 2,000. I end up paying less money if I do this on deal B. So my final conclusion will be I would rent it, or rent the car. This next question is talking about, eventually at the end of the question, about the speed of a car. So it's very important to know your formula for speed, and that is that speed equals distance over time. You may have learned a little triangle kind of pyramid thing in physics. Just as important to understand that speed is distance over time. It's not something which really needs learning because there's a clue even in speed. The units for speed are meters per second. Meters per second. Meters over seconds. And because of that, you know you must be dividing distance by time. A distance unit divided by a time unit. Okay, so back to the question here anyway. So if I'm going to work out the speed here, I'm going to need to know how far the car's travelled and how long it's taken. Well, I'm told explicitly in the question that these photographs are taken 0.5 seconds apart, so I know that my time is 0.5 seconds. So I now need to work out what the distance is. So, how far has the car travelled over that 0.5 seconds between the two photographs being taken? Well, I need to pick a kind of a fair comparison for this car, so I'm going to pick the very, very front of the car. It starts here and it ends up here. So it ends up going 1, 2, 3, 4, 5, 6, 7, 8, 9. It ends up going 9 of those little intervals. I'm told that each of the intervals is 0.6. That ends up giving me 5.4 meters. So very important that I keep the units in both of these. So it travels 5.4 meters in 0.5 seconds. So I'll calculate speed as being distance, which is 5.4 meters over 0.5 seconds. And that's going to end up giving me an answer of 10.8. Yeah, 10.8 meters per second. Again, you can use a calculator. I know I'm sort of avoiding calculus as much as possible in all of these questions so far, but none of them, up to this point at least, have been unreasonable questions to give on a non-calculator paper. It would be unfair to give this many of them because it would take up a lot of your time to do calculations, so you've got a calculator, you should be using it, but it's nice sometimes to do parts of a calculator paper without a calculator just to check you'd be up to it under other circumstances in the other paper. So if I was trying to cope with something like this, it's a nice thing to think about. If I was trying to cope with this, I really don't like the idea of divided by 0.5, so instead I'm maybe going to times top and bottom by 2. That would make the bottom line into 1, the nicest number of all to divide by, and the top line becomes 10.8. That's how I was able to say that the final answer would be 10.8. This bit here, very much optional. That's me trying to do it without using a calculator. So in this question we're told that a lorry is travelling at 13.6 meters per second, and that's compared to a speed limit of 50 kilometers per hour, and we have to decide whether the lorry is travelling below the speed limit. So we need to change one of these numbers so it matches the other one. We either need to change 13.6 meters per second into kilometers per hour, so we compare it to the 50, or you could actually change the speed limit and change 50 kilometers per hour into a speed in meters per second and compare that. I'm going to choose to change the 13.6 meters per second into kilometers per hour. So I need to sort of decide how that changes, what the conversion factors are going to be. And I'm told some useful numbers up here. I'm told that 1 kilometre is 1,000 metres, that's obviously enough, and 1 hour is 3,600 seconds. Okay, that comes from 60 times 60. So this 13.6, how is it going to change? Well, I'm going to be multiplying or dividing by these two factors here. So let's think about it very carefully. If I look at 13.6 metres per second, how do I change metres into kilometres? Well, the conversion factor is 1,000, and if I'm changing metres into kilometres, I'm not going to have very many kilometres. However many metres you start off with, you don't get as many kilometres back out. So that 13.6 metres is going to be made smaller by a factor of 1,000. At this point here, I've managed to change this speed in metres per second into a speed in kilometres per second, and this is a much smaller number, because 13.6 metres per second is not very many kilometres per second. So this is how many kilometres I'm going to be doing in a second. I actually want to know how many kilometres I'm going to be doing in an hour. So I can actually then multiply by that 3,600. This number now, when I calculate what this is, this will have changed metres per second into kilometres per hour. And when I do that, I get an answer of 48.96 kilometres per hour. This number here, 48.96, the speed the lorry is travelling at, is less than 50, so I have categorically shown that the lorry is travelling below the speed limit. This next question is again a conversion question. I am told that a tank contains this much water, that's measured in meters cubed, and I'm then using that to fill pots, and each one of the pots contains that much water, and I've got a mixture of units here because this one is given in centimeters cubed. So I need to change this question so it's all about the same units. I'm going to choose to change 0.6 meters cubed into centimeters cubed, because I know that'd be a large but a whole number. Whereas if I chose to change this into meters cubed, I wouldn't have very many. It would be a decimal, and I sort of try to avoid working with decimals if possible. So let's try and change 0.6 meters cubed into centimeters cubed. The conversion factor to change meters into centimeters is 100, but I'm actually here dealing with meters cubed and centimeters cubed, so I'm going to be times it by 100 3 times. Well, that should be 100. That will give me 0.6 times 100 is going to give me 60, and then I've got these other hundreds, so I actually have 600,000. So 0.6 meters cubed is 600,000 centimeters cubed, and now I simply need to do that division. 600,000 divided by 1250, and you end up getting an answer of 480. You would get an answer of 480 even if you change this number, the volume of each pot, if you change that into meters cubed and divided that very, very small decimal into that decimal of 0.6, which is the amount of water you've got. This next question is a probability question. It also seems to be a little bit of a jibe in case you're at this point in the exam and you discovered that you have not got a calculator with you and you're finding the whole thing incredibly slow going. Make sure you do bring a calculator to your calculator exam. This question is telling you some probabilities of boys and girls turning up to exams with or without calculators. I can look across each row because it's really asking me to understand a two-way table as well. I know, for instance, that the probability of a boy having a calculator is 0.92, so clearly the probability of a boy not having a calculator is 0.08. Those two must add up to 1, because either they have a calculator or they don't. Separately looking at the girl might have a calculator with her, which is 0.95, or they might not have a calculator. So that number there must be 0.05. I did that by saying the total one, take away 0.95, is what gives me 0.05, because these two numbers must add up to 1, because one of them will happen. Being very formal about things, it's an exhaustive list of mutually exclusive outcomes. They're the only things that can happen, and they can't happen at the same time, so they must add up to 1. From this, it would seem to suggest that girls are more likely to bring a calculator than a boy to an exam. The second part of the question says, how many of the 150 boys came with a calculator? I know the probability of a boy coming with a calculator is 0.92. If I want to work out how many people I expect, or an actual number in this case, I times the probability by 150. This probability is almost sort of like a fraction. It's telling you what proportion of the boys had a calculator. So 0.92 of the boys, and there's 150 of them, so 0.92 of the 150 boys. I do that calculation and I end up getting 138. This next question all rests on understanding what congruent means. Congruency is a special case of similarity. We know what similar triangles or similar shapes means. If triangles are similar, it means they're effectively the same shape, they're just changed in size and maybe kind of orientated a little bit differently. Congruency is a special case where, yes, they're similar, yes, they've got all the same angles, it's fundamentally the same shape, but more so, they're the same size as well, so that the sides will be the same length. So these two triangles are effectively the same triangle, same size, same angles, however, they're just positioned slightly differently. This one is a rotation of this one here. So, looking at this here, it says what is the size of angle P? So, this angle here. So, this angle here is the one I'm trying to find. Looking back at this here, I'm going to maybe just try and mark on some distinctive features. This 84-degree angle is on this 8 centimeter length. I can also draw that on over here, and that sort of makes it very clear how this has been rotated. So, it looks to me like this angle here is the same as this one here. Because in this diagram here, this unknown red angle rests on the side which is 8 centimeters long. So it's kind of corresponds to this angle here, which also rests on the 8 centimeter long side. So I'm going to go for an answer of 47 degrees. Secondly, it asks me what is the length PR. So it asks me what this length here is. This length here connects that angle I've just found to an angle which is not 84. So that one there must match up with this one here. Okay, so colour coding this maybe makes it a little bit clearer. So those two sides match up, so PR must be 10 centimeters. In this question, I'm asked to work out the perimeter of this shape here, and this shape is based around this square. This square is the same thing here, and there have been two semicircles added onto the end. The diameters of those semicircles is the same as the length of one side of this square. Excuse me. So, going back up to this square up here, this square's got a total perimeter of 48 centimetres, so I know that each side must be 12 centimetres. So this is 12, 12, 12 and 12. Similarly that's 12, that's 12. That's part of the perimeter already found. These two distances here of 12 won't count towards the perimeter because they're inside the shape. The perimeter just will be this bit here. But they are useful for me working out these curved edges here. So I know these two 12s, these contribute to the perimeter. I need to know the length of this curved side here, which is the same as this one here. Now, you might actually notice straight away that this distance here and this distance here add together to give a total circle. I'm going to just kind of ignore that fact for a second and just find this length and then double it. So if I want to find this distance, this is half of the circumference of a circle. Half of the circumference of a circle, which has a diameter of 12. So I know that the circumference of a circle is pi times the diameter. In this case, that will be 12 pi. And I haven't got the whole circle, I've only got half of it, so I'm going to divide that by 2. I then notice again that I'm going to be doubling it in a second, so maybe a bit of a strange line to put in, but 12 pi divided by 2 gives me this distance, and then I double it, so I end up getting back to 12 pi. That's so redundant, I'm going to put it in brackets. Okay, so I have a total perimeter of 12, 12, and then these two which add up to 12 pi. So my answer will be 12 pi plus 24. Now, that's actually a very good answer. It doesn't actually specify accuracy, so that would actually do as an answer. You could say that the answer is 12 pi plus 24 centimetres. If you do type it into a calculator, you get an answer which is about 61.7. You may choose to round that to 62. That would also be a valid answer. The key thing with these questions is you should really be working with exact values until the very end. Better to work with pi until the very end and then calculate your answer and round than start rounding it in between stages. Okay, this next question says that Amy raised £N for charity. Chris raised £18 more than Amy, and when you average, when you work out the mean of their two values, you get 45. So it's asking to work out how much money each of them raised. Now, as ever in maths, you don't introduce new letters unless you absolutely have to. Amy, we don't know what she raised, it's called N. Chris, on the other hand, though, we don't need to give a new name to that. We don't need to say that Chris raised M or anything like that. Chris raised £18 more than Amy, so he raised N plus 18. And I'm now going to work through this question using these two numbers. Amy raised N, Chris raised this much. So if I wanted to calculate the mean of those two, just imagine I knew what the numbers were. I would be adding those two numbers together and dividing by 2. I'm going to still do that even though there's algebra involved, but I know what my answer would be. My answer is going to be 45. So I know I'm going to add Amy's amount to Chris's amount and divide by 2. I should get an answer of 45. That's the key setup of this question. Be very careful that you're divided by 2 because there are 2 people contributing to this, even though there are 3 terms at this point. I'm going to tidy that up a little bit. I get 2n plus 18, all over 2 equals 45. I'm going to try and find out what n is. First thing I don't really like about this is this divided by 2, so I'll get rid of that by multiplying both sides by 2. The effect of multiplying both sides by 2 is to get rid of that dividing by 2 that I didn't like, and I end up getting this line here. I'll get that 2n is 72. When I divide by that, I'm going to get that n is 36. N I see from the beginning of the question was how much Amy raised, so I now know that Amy raised 36. Chris raised £18 more, so I'll simply add 18 onto that. I can't quite write it on there, but Chris then raised 54. We're now asked to do a question about standard form. This is very, very easy by the presence of a calculator. Again, you could do the question without a calculator, but with a calculator, this is just a case of typing this in so it appears exactly as it is here. You can just type these both in exactly as they appear, do the multiplication, and you end up getting an answer of 1612.5. It won't necessarily give an answer out in standard form. However, the question does want my answer in standard form, so I need to translate this answer into standard form. So standard form requires this number to be between 1 and 10. So I'm going to write 1.6125. Okay, that's the same as this number here. It's just a lot smaller. I've made it smaller than it was. So I then keep it in standard form means you always multiply by 10 to the power of, now this number that I've written down is smaller than the number I'm actually dealing with, so I'm going to put a positive power here. I need to multiply by 10 lots to get this up to this number here. I'll go back and investigate how many kind of differences there are, how many jumps difference there are between where the decimal point actually is and where I've placed it. So there's 1, 2, 3. I'm either multiplying by 1,000 here or dividing by 1,000. I'm actually multiplying by 1,000, so I will write down here a power of 3. There are 3 jumps difference between where the decimal point actually is in this number and where I'm placing it in my answer. If you didn't have a calculator, if this was a non-calculator exam again, you would go back to this question here. You would do 6.45 times 2.5. You would do that by maybe doing 645 times 25 and then fixing your answer by introducing back in 3 jumps to make it smaller than it was. You would then do 10 to the 6 times 10 to the minus 4, which gives you 10 squared. So whatever answer you got for the multiplication of the 2 numbers, you would times by 100 and you'd get the same answer and you'd transform it into standard form. 14b is giving me a number machine. It's saying some input's been put in, you took away 1,000, divided by 20, and you ended up getting this answer here. So it's saying what was that input that gave me this output. So I'm going to run this machine in reverse. I've got 5.05 times 10 cubed. I'm starting with that number there. As I go backwards through this machine, instead of dividing by 20, I will times by 20. And then instead of taking away 1,000, I will add 1,000. And when I do that, I get an answer of 102,000, 102,000. Notice I'm running the machine, I'm working through it in reverse. So the last thing I did to the input is the first thing I do to the output, and I'm doing the opposite, the inverse of each of these things. Running in this direction, you take away 1,000 and divide by 20. Running in this direction, you multiply by 20 and add 1,000. This answer here is the correct number, but it's not in standard form. So again, I need to write down a number which is between 1 and 10 that represents all those digits. I'm going to go for 1.02. And I'm then going to go back to this number here. I'm going to say that the decimal point I've introduced, I've put there. I have introduced a decimal point between the 1 and the 0. And the decimal point is actually right here at the end. So how many jumps worth of difference? How much multiplying or dividing by tens am I doing? 1, 2, 3, 4, 5. So it definitely features 10 to the power of 5. I just take a second to decide, is it definitely a positive 5 I want? Yes it is, because this is a large number, so I want this to be a large number, which means a positive index. Also, this number is a small number being times by 10 repeatedly. That will turn it into the number I wanted it to be. This next question is a functional maths question as well. I have to be very clear to make sure all my steps are clearly laid out here. And in this question, I'm going to try and work out a missing number. There is a number here. I'm trying to work out what this jacket cost. I know that when I add the cost of this jacket to a t-shirt costing £29, I get a total. I then reduce that total by 10%, and I end up getting a total afterwards of £80.10. So I'm going to work backwards through this question. I'm going to kind of work back up this question. So I know that after the discount, I was paying £80.10. I need to know what that total was before the discount. So I need to be very careful that I'm told here the amount after a discount of 10%. So my crucial thing to identify is that I've been told 90% is that. Okay, I've been told here 90%, and I'm trying to go back to work out what the original 100% was before the 10% reduction. So this is a reverse percentage question. So in trying to change 90% back into 100, excuse me, I work out what, sorry, I'm allergic to percentages. 90% changes into 1% by dividing by 90. So I divide both sides by 90, that's 80.1 divided by 90. And then I change 1% back into 100 by timesing by 100. So I get 80.1 over 90 times 100, and that's a number I can evaluate. I end up getting an answer of £89. So even at this point here, you could check that's right, that makes sense. If you think about £89 and a 10% discount, 10% that's easy to find, it's £8.90. When you take off £8.90, you do in fact get £80.10. So at this point I've identified the total here. I know the total when the jacket and the shirt are added together gives me £89. So if I remove the cost of the shirt, I'll be left with the cost of the jacket. So I do 89, take away 29, gives me 60. So the jacket must be 60. As a quick check at the end, you could take your 60, add on 29, work out 90% of it, and you should get this number as your final answer. Here we're given two coordinates, coordinate A and coordinate B, which both feature algebra. and we're told that when we find the midpoint of those two, the point exactly halfway in between both of them, we get this value here. So I'm going to try and work out what the midpoint of these are, set it equal to this, and hopefully that should allow me to find what x and y are. So to find the midpoint of two coordinates, which are normally numbers that we know, you would average out the x coordinates, that should give me -4, and you would average out the y coordinates. So I'm effectively doing this. I'm doing x plus 3x divided by 2. I'm finding the point halfway between x and 3x, and when I do that, I will get an answer of -4, according to the answer I've been given. Before I think about the y coordinates, let's just follow that through a little bit. That can be tidied up. I'm going to times, well, I'll tidy up the top line first of all by saying that's 4x over 2 equals -4. That's actually just 2x equals -4, and I get an answer of x equals -2 even, sorry. Let's see, that's -2. Because in going from here to here, I needed to divide by 2 to get x by itself, so I divided this value by 2. So I know that my x coordinate is -2. At this stage here, you may have not liked the look of this 2, you may have multiplied both sides by 2, you would have got 4x equals -8. Dividing both sides by 4, you will still get the same answer there. So I've managed to work out what x is. Okay, I'll maybe even write this down here already. I'm going to do a similar thing now with the y coordinates. So I know that when I average out those two y coordinates, that means adding them together and dividing by 2, I get an answer of 15. When you do actually calculate 2y plus 4y, you get 6y. 6y over 2 is 3y. If 3y equals 15, then dividing both sides by 3 gives me that y is 5. In this question here, I'm given a right angle triangle, I'm given two sides and I'm asked to find an angle. As soon as you see triangle questions which involve angles and sides, it's definitely a trig question. Okay, don't be overcomplicating this question. It doesn't require sine rule, cosine rule, anything like that. It's got a right angle, so it's regular boring trig. It's just sine, cos, and tan. Okay, so looking at this question here, the first thing I might do is I might label the sides. So I'm talking about this angle. So I can label this as being the opposite to that. This is the hypotenuse because it's opposite the right angle. This one here, this 12, is labelled sort of by default as the adjacent. I mean, obviously, both of these sides are adjacent to it. Why are we choosing to call this one the adjacent? Well, because this one is called the hypotenuse. All the sides are labelled. They are labelled, crucially, depending on the angle I'm interested in. If you're interested in a different angle, these labels would be different. So now, I am now going to try and write down an equation about x. I notice straight away that h isn't really going to feature in my question here. Okay, I'm trying to find x, and these are the things I know. In a trig like this, you're only interested in things you know and things you want to know. This is neither. So, this question is all about O and A. I know all my little reminders. The one which features O and A is TOA, so I know that this is a tan question. So you immediately write down tan. There's probably a mark in this question for any site of tan. That's the kind of phraseology they use in the mark scheme, site of tan. So we've used tan, we've correctly identified we need tan. You always take tan of an angle. It doesn't matter whether you know it or don't know it, you are taking tan of an angle. So tan of x is equal to tan of an angle is equal to opposite over adjacent. So the opposite is 7 and the adjacent is 12. So at this point here, I've set up an equation that's worth a lot of marks already, probably 2 out of the 3 marks. And at this point here, I'm going to try and say, well, what is the value of x? How am I going to get x by itself? Well, the only thing stopping x being by itself is this tan. Tan is interfering with x being by itself. I want to get rid of tan. We're very familiar with lots of other inverses. If you'd multiplied x by a number, you would have divided. What I've done here to this number x is I've done tan to it. The way I undo tan is using this tan to the -1 thing. So this inverse tan function, shift tan on your calculator. I'm going to do that to both sides. That removes the tan and leaves x by itself, and it just does whatever it does. I know, but you won't know for a few more years yet. So, well, next year even. So tan to the -1 of 7 over 12 is something I'm going to calculate. I type that into a calculator. I get an answer in the region of 30 point something, 30.256. I'll write that as 30.3. So my answer is 30.3. 30 would be fine as well. I wouldn't go more accurate than 30.3. Because it doesn't pay for you to be more accurate really than the question. The question didn't have any decimal places, so I wouldn't go more than one more decimal place. The next question here is asking me to work out a length. This triangle here is not right angled, so I'm not going to be able to use regular trig. I'm going to have to use the sine or the cosine rule. And looking at this here, I'm not going to make any judgments in advance. I want to find the length BC. I'm maybe going to give it a name. X was used in the previous question, so I'll call it Y. My kind of favourite of the sine and cosine rule is the sine rule. I think it's easier. I think it's slightly more reliable to use, so I'm going to try and use the sine rule. If that fails, I'll have to use the cosine rule. So the sine rule pairs up sides with the opposite angles. So these match up and these match up. So it's looking promising here that I've got enough information. You can choose whether you put sides on the top or angles on the top. This is all on the first page of the exam and the formula booklet, but I'm going to choose to put sides on the top because it's the side I'm trying to find. So very consistently, I write y, that's this side, I pair it up with the opposite angle, and it's called the sine rule because you're taking the sines of those angles. Even in the sine rule, angles are never left alone. Sine rule, cosine rule, regular trig, angles are always prefixed by a sine, a cos, or a tan. So anyway, I've paired up these two, okay, and this contains an unknown piece of information, but luckily the other pair I know is entirely known to me. So again, just like before, I've chosen to put sides on the top and sines of angles on the bottom. So I get to that point there, and I'm going to try and get y by itself. This thing here is something I can calculate quite easily. It's just an awkward number. Y is being divided by an awkward number. I'm not going to evaluate anything just yet. I want to get y by itself. I don't want it to be divided by sine 40. So I'm going to get rid of that by timesing both sides by sine 40. It's just a number, and I'm going to multiply both sides by that number. So y will be equal to 18 over sine 110 times by sine 40. You might have written that sine 40 on the top line with the 18. It's the same thing because really that sine 40 is sine 40 over 1. Okay, so now I just type into my calculator 18 divided by sine 110 and multiplied by sine 40, and I get an answer of 12.312725, etc. I'm going to write down a fairly sensible rounding. I'm going to go for 12.3. I'm not going to be more accurate than the question is. One decimal place, which is one more than the question had. Okay, this question I'm asked to draw a box plot. I'm going to try and draw as accurate as I can, but bear in mind I might not be able to draw my lines exactly where I want them to be. A box plot, I'm going to start by doing the main box. The box is going from the lower quartile to the upper quartile with the median marked on. So I'm going to start with the lower quartile, which is 18. I'm going to try... Oh, that's quite good. My upper quartile is 30. Oh, this is going well. That's less so. There's my box. Okay, so I've already used that piece of information and that piece of information, and I'm now going to use the median. So the median is at 23, and so I'm going to put in the median there, and that's the box. Okay. Now, in addition to that, we extend this to show what the minimum and maximum values are. So I'm going to draw what someone's called a whisker going down to 9. Oh, this is brilliant. So there, I've got that 9 there. The maximum is 45, so I'm going to do a little line here at 45, not so good, and I end up with this. One important misconception is that people assume that the median, this line here representing the median, must be in the middle of the box. If you draw out a list of all the values, the median, the middle value, will be halfway between the value which is the lower quartile and the upper quartile in terms of where they are on the list. Their values, on the other hand, don't need to be equally spaced. Okay, so the value of the median can be closer to the lower quartile than the upper quartile. There's nothing wrong with that. But it would be true that when you sort of write all those numbers down, this number would be equally spaced between these two. It doesn't mean the value of that number is. Okay, it's quite a subtle point. In this question here, I'm going to draw a histogram. The crucial thing, the only thing you need to really know about a histogram is that area is frequency, or frequency is area, whichever way around you want to do it. So the area of my bars are going to be representing the frequencies. Okay, you can love formulas for things like frequency density, but it all comes from understanding that area is frequency, frequency is area, and knowing a little bit about rectangles. So I'm going to think about this very first one here. I'm going to do this with the bare minimum of knowledge. So as I've lived my life. So here, this distance goes from 0 to 10. So I'm going to be drawing a bar that goes from 0 up to 10. And I just need to know how high up that bar is going to go. Now, I know that the area of that bar has to be frequency, has to be 17. So I'm going to draw myself a little diagram of this. There's the bar I'm going to draw in a second. And it goes from 0 to 10. So the base of this has got a width of 10. What I don't know is this height here. I don't know how high up that bar is going to go. but I do know that it's going to end up having an area of 17. So I'm trying to find a missing value, a value which is a height, which when I times it by 10 gives me 17. So I can see that I'll be finding x by doing 17 divided by 10. So 1.7. So this goes up to a height of 1.7, like that. Now, that thinking can be avoided if you've learnt off that frequency density is frequency divided by width. That's absolutely fine. I always try and kind of prioritize the most important things in maths and try to not learn anything else I don't need to learn. So I've understood the height of this bar. Very important, just while we're at it, to think about why we've called this frequency density. The most common label that could be given other than frequency density, a wrong label, would be frequency. It isn't frequency because height is not frequency. Area is frequency. This has to have a different name, and we just go for the name frequency density. Okay, so once I've done this thinking here for the first question and sort of established how I work out the heights, I don't need to do this every time. So I'm going to keep using the same method. I'm going to find out the second frequency density by doing 12 divided by 5, which gives me a frequency density of 2.4. For the next one, I do 3 divided by 5, so 3 divided by 15 even, which is 0.2. And finally, I do 9 divided by 30, which gives me 0.3. And I'm going to transfer these on now. So the second bar goes from 10 to 15 and has a height of 2.4. Like that. If you check the area of that bar, if you do 5 times 2.4, you do get a frequency of 12. Area is frequency for that bar. The next bar goes from 15 to 30 and has a height of 0.2. So I have this bar here. Again, if you do 30 times 0.2, you do indeed get 3. That's why we picked to have that height. That's why we picked that frequency density, so that its area would be its frequency. And the final one goes from 30 to 60. It has a height of 0.3. That's quite well drawn. And I get that. And that's a diagram, which is a histogram, areas of frequencies, showing the distance travelled by these employees. Okay, in this question we're asked to solve a quadratic. It's quadratic because it's got an x squared term and nothing higher, nothing more interesting than an x squared, an x and a number. We've got lots of different ways of solving quadratics. See how many you can think of now. Right, that's enough waiting. You could do it by factorization, you could do it using the quadratic formula, you could do it by completing the square, you could do it by trial improvement, though you would usually avoid that unless a question specifically asks you to do it that way. You could even do it by graphing this and seeing when it's equal to 0, that means when it crosses the x-axis. You could guess. There are loads of different options here. Okay, there's a drawback to all of those methods in this case, apart from one of them. The dead giveaway really is the 2 decimal places part here. We're going to solve this using the quadratic formula. Factorization actually fails for this. You wouldn't be able to factorize it. That doesn't mean there aren't answers. We're going to find some answers. Just means that factorization is not the best method. This 2 makes completing the square difficult. The other ones all have their drawbacks. If you see a question like this with a specified accuracy, it probably means the quadratic formula. So the quadratic formula is given on the first page of this exam. Nobody sets out to learn it, but if you've done enough practice, you end up just picking it up as you go along. You get minus b plus or minus b squared minus 4ac all over 2a. A, b and c are things we now need to identify. It's really just a substitution question now. So a, b and c are got from the original equation. Provided you've got it equal to 0, you look at this side here. A is the number in front of x squared, so in this case it's 2. B is the number in front of x, in this case it's 8, and c is the number by itself on the end, so in this case that's 5. It's not because they appear in the order a, b, c. A is always the number in front of x squared wherever this term appears. Be very careful of any minuses as well. Here we've got all positive numbers. So let's plug that in. I've got minus b plus or minus the square root of b squared, which is 8 squared, 64, minus 4 lots of a times c, all over 2 lots of a, and 2 lots of a is 4. I'm going to now focus on making sure I evaluate this correctly. This bit's so important it's even got a name. It's called the determinant. Here, these are both positive numbers, so this is a positive number. We're going to have 64 take away a number. If one of these was negative, it would make this a negative value, and taking away a minus means you'd actually be adding 2 numbers together. Be very careful of the signs going on in here. The formula itself brings a takeaway. These may be positive or negative. So my next line is minus 8 plus or minus the square root of 64, take away 4 times 2 times 5 is 40, all over 4. That gives me answers of minus 8 plus or minus root 24 over 4. Those answers are in surd form. I need them to 2 decimal places. So at this point here, I separately type in 2 calculations into my calculator. I'm going to work out, first of all, -8 plus root 24, so plus, all over 4, which gives me a particular answer of, in this case, let me just work that out, it gives me an answer of minus 0.78. And when I do the other one, -8 take away root 24 all over 4, I get another answer which is minus 3.22. That's rounding the numbers to 2 decimal places. Minus 0.78 and minus 3.22. One thing I notice here, again, this is beyond what you're being asked to do, but just to practice surds a little bit, looking at this thing here, I actually notice I could simplify this down. Now, you're still going to type it in the calculator for the purposes of this question, so it doesn't really do us any benefit here, but just in case we're asked to simplify something as part of a surd question, I know how to simplify root 24. I can know that that surd can be simplified because I can think of a square number that goes into that. I know that root 24 equals root 4 times root 6. Root 4 is the one I know, which is 2, so 2 root 6. So this is equal to -8 plus or minus 2 root 6 all over 4. Now, both the things on the top are even, so is the number on the bottom, so I can sort of divide through by 2. I get -4 plus root 6 all over 2. I've sort of cancelled a factor of 2 there, a factor of 2 there, and a factor of 2 there. Okay, that, as I say, completely surplus to this question, but just something nice to notice. The next question is an algebraic fractions question. It's telling you that you started off with this expression here, which contains a little bit of algebra, and it's been simplified down to this. We need to work out the value of b, so we always sort of need to work in reverse. Now, this is interesting because here, obviously, this question here, this must have originally been x plus 3 and x plus 5, and there must have been some other bracket going on there, something else which cancelled out to give us this thing here. Okay, so in simplifying, we cancelled out a factor on the top and bottom. I need to know what that factor is. Now, looking back at this original one, x squared minus 9 is something I can factorise. X squared minus 9 is a difference of 2 squares. So this original expression is x plus 3, x minus 3, all over x squared plus bx minus 15. I've noticed that this thing here is a difference of 2 squares. What squares to give x squared? It's x. What squares to give 9? It's 3, and a difference of a plus and a minus in each of the brackets there. So this thing here, now something has cancelled out. Something cancelled out to just leave this x plus 3. So it must have been an x minus 3. This missing thing here which disappeared was an x minus 3. So there must have been an x minus 3 on the bottom line. So I now have this crucial thing on the bottom line. I now know that this must be this. X plus 3, x minus 3, x plus 5, x minus 3. In a second, those are the things which cancel out. But at this stage, I know, I've gone colour mad here, that this thing is the same as this. This takes a bit of thinking here. You might need to listen to this once more. So I know that when I expand this, I should get this. So let's expand this thing over here. X plus 5, x minus 3, x minus 3 gives me x times x is x squared. First outside gives me minus 3x, inside, last gives me x squared plus 2x minus 15, and so the value of b must be 2. It's a very good question. So again, just one last time, this is my simplified expression, so there was some bracket that cancelled out from here. I know that the top line was originally x plus 3x minus 3. So it must have been an x minus 3 that disappeared in going from here to here. So there must be an x minus 3 as part of this. This must be here, x plus 3x minus 3, x plus 5x minus 3. Okay, this is where the cancelling comes from, and I'm just sort of expanding this back into the original expression. Okay, so in this question here, we're being given 2 interesting looking solids. I can see that one of them is shorter than the other one of them is a bigger volume than the other one. I need to try and work out how I've gone from here to here. So the first thing we're going to look at is how this length has changed into this length. It hasn't been doubled, it hasn't been halved. I can see it's gone up by a certain factor. It's gone up by a factor of 12 over 10, 1.2. Okay, you may have just noticed that straight away. What I'm doing is I need to multiply 10 by 1.2 to turn it into this number. In going from here to here, I am multiplying any of the lengths by 1.2. That's what we call my kind of linear factor. Okay, my linear scale factor rather. Okay, now I'm trying to work out how the volume has changed. Now this one originally had a volume of 500 centimeters cubed, and I'm trying to work out what is that going to change into. Now, we have to be very careful in questions like this that although the length has got 1.2 times bigger, the volume changes by a slightly different factor. Okay, the length changes by a factor of 1.2, the volume changes by a factor of 1.2, by 1.2 and by 1.2 again. You have to cube the 1.2. So, I know that that original 500 is being times by 1.2 cubed, just like when we're changing squared units or units of volume. In fact, we did a volume question a bit like this earlier on. You have to be very, very aware that whatever the factor is for lengths is going to be cubed for volumes. I then just need to evaluate what this is. Back to black for this one here. And so I'm going to get an answer of 864. So again, you always identify what is the kind of length scale factor, in this case 1.2, and then you're aware that volumes would change by a factor of 1.2 cubed. If you've been told an area for this one, you would change areas from this shape into areas of this shape by times them by 1.2 squared. One other way you could have thought about this, you could have been thinking about how you change this into this, in which case that direction would have been timesing by a scale factor which is smaller than 1, because lengths are getting smaller. In going from 12 to 10, things get smaller. They get smaller by that factor there. So you could have worked with that factor there, in which case you would have said that this mysterious value here is being times by 10 over 12 cubed, and it's giving you an answer of 500, and you could have worked from there. Okay, so now we've got a probability question. This question is talking about taking counters out of a bag. I've got a nice big space here which is suggesting maybe a tree diagram would be a good idea. It usually is. So I'm going to sort of draw a kind of branching diagram of all the possible things that can happen. So I'm starting here from like the beginning of the universe. The first thing I do is I reach in and I take out a counter. And at that point the universe splits into two. Okay. I might get a white counter. I might get a counter which is not white. Rather than give that a different name, I'm going to use that notation there. There are lots of other ways of indicating that something is not white. I've gone for white with a dash above it. So, at that point there, white or not white. Now, I'm not actually told what colours are in here. There might be all kinds of different colours in this, okay? Rather than splitting my tree diagram into lots and lots of branches, this question's only interested in whether things are white or whether they're not white. So that's the only branches I'm going to do. Okay? And at this point here, let's think about the probability of me ending up in either of those situations. The probability of me picking a white counter the first time I reach in is 5 out of the original 12. So I have a probability of 5 out of 12. So I must know that there are then 7 counters which are not white. So my probability of picking a counter which is not white is 7 over 12. Now, I then reach in a second time. So, I may have gone along this path, I may have gone along this path, but now the universe splits into two paths again. You might get a white the second time, or you might not get a white the second time, and that can happen irrespective of what happened the first time. So, before I label any probabilities, this path here means I got a white the first time and a white the second time. This path means I got a white and then something which wasn't white. Here, not white and then white. And here, not white and then not white again. Now, these probabilities here will depend on what's happened the first time, because I can see that I didn't replace the original counter. It matters what happened the first time, what will happen the second time. So let's have a look. Now, I am very much here at this point, considering the probability of being white or not white. So here, the first time, there were 5 white counters out of the total of 12. When I start going along one of these branches, there are definitely only 11 counters left. So, if I am here, I've already taken out a white counter, so there are now only 4 counters left. So I'm going to write a 4 there. Either by just comparing that these two must add up to 11, I can see that this one is 7. The reason it's also 7 is because originally there were 7 non-white counters. All 7 of them are still there. All 7 of those non-white counters, because none of them were taken out. Let's think about this path here. If you've ended up here looking along these two branches here, you picked out a counter which wasn't white. That means the original 5 white counters are all still in the bag. but you did take out one of the counters, a non-white counter, meaning there are now only 11 counters left. The probability which pairs up with that, well, one of these two things must happen, so it has to add up to 1. So I'm going to write down 6 over 11. Can't be right. Yes, it can be, sorry, 6 over 11, because originally there were 7 non-white counters. I took one of them out, leaving me with 6. Here, you're reaching into a bag with 12 counters. Here, whatever happened first of all, you're reaching into a bag with 11 counters. So there are various places I can end up. Okay. Now I'm going to multiply along the branches and add the different options. It's kind of an and and or situation. If you go along here, this and this happened. If you go along here, this and this happened. If you just want one of them, it's one or the other. So let's think about what I'm actually asked here. I'm asked the probability that only one of the counters is white. It's not both, it's not neither, only one of them is white. So that means I must have gone along this path here or this path here. I'm neglecting this path because both of them are white along that path, and I'm ignoring this path because neither of them are white along this one. So I either want this path or this path. So I want this and this to happen, or this and this. So let's write that down as maths. So I've got 5 over 12. I'll write that as maths in black. So I've got 5 over 12 times 7 over 11. Just put that in brackets to make it clear. That's my probability of going along this path. This happens and this happens. My probability of going along this path is 7 over 12 times 5 over 11. So I've got my probability of passing along this path, my probability of passing along this path, and I want that one or that one. Or translates into a plus. And is multiply, add is or. Okay. At this point here, it's just a calculation to be worked out. So I work out what these are. You could do this even in a non-calculator exam. You work out what this all adds up to, and you end up getting an answer of 35 over 66. My final answer is 35 over 66. There is an intermediate fraction that you get, but you should really always try and cancel down fractions into the simplest possible form. You could then turn this into a decimal, but really the fraction is better. The whole question could have been done with decimals, but that would be a bit of a bad idea. One very crucial piece of advice that doesn't apply here: if you're drawing a tree diagram, don't ever simplify any of the probabilities labelling the diagrams. It's much easier to work out these probabilities here based on these ones if you haven't simplified. Don't simplify until your final answer. So now we've got a vector question. We're presented with this shape here, and we're told some certain facts about it. We're told some labels that we've got. We're told that AB is 5p. This trip here is 5 lots of a vector called p. We're told that DC is just p. So this one here is 5 times longer than this one here. We can see from the diagram we're told that this one is parallel to this one, but we also know it from the information given. 2 vectors are parallel if one is a multiple of another one. This will be very useful later on. This 5p is just a multiple of this. It's got the same direction, but just a different length. It's just been slid over to here. And we're also told that DA here, this one here, is called 2q minus p. It says, show that CB, that's this little journey here, is equal to 2q plus 3p. I'm not going to really pay any attention to this. I'm just going to try and work out what CB is in terms of p's and q's and hope I get this answer here. So I'm going to set off on a journey then from C going all the way around to B, and I'm going to go on this rather long trip here like this. So I'm going to maybe write down a little bit more than I maybe need to here. I'm going to say that CB is the same thing as me going from C to D, and then going from D to A, and then going from A to B. So this vector is the same as these series of paths here. This journey here is the same as me taking this rather longer route round here. So I'm going to write down now the names for all of those. I know that CD is called minus P. It's minus P because I'm going along this in the opposite direction. P labels a particular length of vector, but also in a particular direction, and I want to go the other way. I'm now going to go up DA. DA I know the name of. It's just called 2q minus P. And then finally I go along AB. AB I know is 5p, so I add on 5p. Now, just like with kind of regular algebra, I'm going to collect this together. I've got a minus p. I take away another p, that gets me down to minus 2p, and then I add on 5p. That gives me 3p. So I've got 3p's. How many q's have I got? I've got 2q and I end up getting exactly the same thing as I had here. Notice I've been very careful to make sure I underline my letters. You don't try and emulate this bold font that they use. Anytime you see a printed vector, it'll probably be in bold. You don't try and replicate that, you just underline your letters. So I've established this first thing here, and I've proven what CB is. So let's look at this next thing here. So it says, next of all, M here, this point here, is in the middle of AD. Okay, we didn't stop off on our journey earlier because we may as well have just gone straight from D to A. And I'm told where N is. N is positioned such that AN is 2 parts and NB is 3 parts. It now asks me to show that MN is parallel to CB. So I can leave all this working on the page. I'm going to do my answer over here. So I'm going to try and work out what MN is. So let's have a look at what MN is. MN is equal to, well, I'm trying to go from here to here. So MN is going to be equal to MA plus AN. Rather than go directly from M to N, I'm going to go via A. I'm going to go MA, MN. Mun is equal to Ma-an, so to speak. Okay, so here these two need to match up because it's the point you're going via. So at this point here, I'm going to write down what MA is and what AN is. So MA is, excuse me, if I was a professional, I'd probably stop and redo this, but I'm going to keep going. MA is this little bit here, and I know that MA, because I'm told, is, yeah, because M is in the middle of AD, I know that MA is half of whatever DA is. So MA is half of DA. I know what DA is. DA is this thing here, so I want to work out what half of that is, so I know that MA is equal to Q minus a half of P. I'll maybe just write it like that. You could write a fraction half instead. So I now know what MA is, I know what this bit is. Now I need to write down what AN is. So let's see what AN is. AN is, it's a journey from A to M, which is only part of the way across from A to B. It's not the whole way from A to B. I know that it's 2 out of the total of 5 parts. This is 2 parts, this is 3 parts, so AN will be 2/5 of AB. I know that AB is 5p, so 2/5 of 5p is going to be 2p. So I can now write down what MN is, because I know both of the things which make it up. So I now know that MN is equal to Q minus 0.5p plus 2p, which gives me 1.5p plus Q. This minus 0.5p plus 2p gives me 1.5p, and there's just a Q there. So I need to actually try and establish that I have shown that MN is parallel to CB. We mentioned at the very beginning what the condition is for things to be parallel. A vector is parallel to another vector if one of them is a multiple of the other one. So I'm hoping that MN is a multiple of CB, multiple of this. And I can see that it definitely is. I mean, if I maybe compare this one and this one, I can see that if I times CB by a half, I end up getting MN. So these vectors are a multiple of each other, and that proves that they're parallel. So I'm now going to write down that MN is a multiple of CB, so they are parallel. That's quite a deep question. Part A is not too bad in terms of just finding a different route to work out what CB is. Part B is just trickier. You have to do a lot more along the way, and you have to know your facts. You have to know that geometric fact that vectors are parallel if one is a multiple of the other one. Okay, so now we're being asked to do a graph transformation. So we're being given here the lovely wibbly wobbly graph of sine x. It sort of does this, and it keeps doing that forever and ever and ever. It goes up and then down a bit lower and then back up again, and this just repeats on and on and on. Now, I'm asked to transform this, to change it. So they've given you this graph, and they're saying instead of drawing sine x, they want you to draw 1 plus sine x. So there's been a number added on to sine x. It's not been added on directly to the x, it's been added on to the whole total function. So if we're going to employ some of that function notation, here we've really got fx, that's what sine x is, and here we've got 1 plus fx. You've added on a number to sine x. So all the values have got 1 higher than they were before. Interesting things still happen in the same place. For instance, here we see something nice. When you plug in 90 into this function, you get this kind of high point. Sin x gives a really nice high value when you plug in 90. Here, if you plug in 90 into this thing here, you still get that nice high value, and then it goes up even more. It moves up 1. If you even look over here at this really low point over here, we know that sine of 270 gives me -1. It gives me a very interesting low point. When I plug in 270, I get out -1. Well, if I plug in the same value of 270, what I'm putting in is unaffected. I still work out what that value is. I still get that nice low point of -1. It's just not quite as low as before because it gets moved up 1. Every single value comes out the same and gets moved up 1. The easy way of learning that is just that if you have a number outside of fx being added on or subtracted, you move the graph up or down in the way you would expect. So here I'm going to sort of give myself a few points to work with. That one's moved up 1. That one's moved up 1, that one has moved up 1, this one's moved up 1, this one's moved up 1. I get a sine graph that looks like that. Okay. So there is my new graph. My original graph was there. So I'm asked to do a second transformation here. And this says, again, you've been given the graph of sine x. We're told what that looks like. We can work out certain values for it. This is sine x. And this time, we're being asked to say what is 2 lots of that value of sine x. Notice I'm multiplying this whole thing. I'm not multiplying the x itself. So again, this is a transformation where I'm changing the values I get out, not the values I put in. So with a very similar thinking to before, let's look at some of the interesting points on this graph. Okay, you may have memorized what this means already. If you have, you already know what to draw. So looking at this here, I'm saying that when I plug in 90, I get that interesting point, that high point of the graph. When I plug in 90, I get out a value of 1, which is the high point of this graph. If I plug in 90 to this, I still get out 1, and then I double it. So this point here moves up to here. So it looks a bit like it was the same question as before. Let's investigate this point though. When I plug in 0 to this thing here, to this graph of sine, when you do sine of 0, you get out 0. So let's plug in 0 into this new graph. When you do sine of 0, you still get 0, and then we double it. The effect of doubling 0 leaves it unchanged, and that stays where it is. So my new points are looking like this. Let's investigate this point here. When I put in 180, I get out 0. So just like before, you used to get out 180, now you double that answer, so you still get 0. You still get out 0 when you put in 180. You double the 0, you still get 0. Now looking at another interesting point, let's look at 270. When you plug in 270 to sine, you get out a value of -1. So when I plug in 270 into this, I get a value of -1, and then I double it, it becomes -2. So it moves down to there. And again, this 0 stays unchanged. So you may have already learnt that when you draw the graph of 2f of x, it is a stretching in this vertical direction by a factor of 2. Points on the x-axis stay fixed. Okay, this doesn't really change the frequency of this, but it does change its amplitude. To do a bit of physics, if you're thinking about this being a sound wave, then this is a louder sound wave. It still has the same pitch. The frequency is unchanged, so it still has the same pitch, but its amplitude is changed, so it's got a louder volume to it. To finish, we have a nice piece of algebra here, solving an algebraic fraction question, an equation rather, with algebraic fractions in it. One thing just to note, this will be useful along the way, let's just remember how we add together normal fractions. So if I'd wanted to add together 2/3 and 1/5, I would need to get a common denominator. I would need to change 3 and 5 into a nice number, okay? So I would go for 15 in this case, okay? So I would be timesing this one by 5 top and bottom to make this 15, by timesing this top and bottom by 3 to make this into 15, okay? In Form 1, you may remember that sort of one way that always worked is a common denominator that works is always just to multiply these two things together. I mean, sometimes there are shortcuts. If I'd asked you to add together these things here, you may have spotted that there's a better denominator there. You probably would leave this one alone, and you'd times this one by 2 to make it into 4. So a better common denominator in this case would be 4, but you wouldn't be wrong if you went for a denominator of 8. If you times top and bottom here by 4, if you times top and bottom here by 2. So let's look back at this and let's just think about this with a bit of algebra going on. Now, I think it's sometimes easier to just put the brackets in around those pieces of algebra on the bottom line. I need a common denominator. I'm trying to think of something I can turn that into and that into. I'm not going to have some clever piece of inspiration. I'm just going to go for an obvious one that works. In fact, in this case, it is the best one that works. So I'm going to change x plus 2 into x plus 2, x plus 1. So that top line that used to just be a 5 has picked up an x plus 1. All I've done here is rewrite this piece of maths like this. It's an equivalent fraction. If you think about simplifying algebraic fractions, that cancels out. If they go away, you have exactly the same thing. I am just overcomplicating this. I'm writing it a more difficult way, really. Okay, it's going to be useful later on, but for now, these are the same. This just really should be simplified down. I'm now going to rewrite the other fraction. It already had an x plus 1 on the bottom line. I'm going to times it by x plus 2. So the top line also picks up an x plus 2. Again, here, you could cancel these out and you'd go back to there. Nothing has changed at this point. This piece of maths here is exactly the same as this. The advantage of it is that I've got the same denominator, a common denominator, the thing I always want so much. And so my answer then is going to be equal to 2. This side here has not changed. Okay. Now, at this point here, I am able to add these together. Okay, so I can add these together with a common denominator, and I get x plus 2, x plus 1, and on the top line, I have 5x plus 1, which is, I'll write it out as I go, 5x plus 5, and then I add on to that this thing, which is 4x plus 8. And that's equal to 2. So now I'm going to tidy up the top line. I have 9x plus 13. And on the bottom line, I'll maybe expand this. It's not necessary at this stage, but I'll do it. I get x squared plus 2x plus x, which is plus 3x, plus 2 equals 2. Now, that doesn't look nice. The thing I don't like about this is I'm dividing by a great big chunk of maths. I don't like dividing this by this horrible piece of maths, so I'm going to times both sides with this horrible piece of maths. That will cancel out this division. So timesing both sides by that, this side will just become 9x plus 13, and this side will become 2 lots of that. Sorry, you can't see that, but loads of things have appeared on the screen. I didn't want to. Let's see what happens if I do that. Okay, sorry. So, at this point here, I've got this quite a nice equation. If I was presented this at any point in the exam, I wouldn't be too troubled by this. So I've got 9x plus 13 equals 2x squared plus 6x plus 4. This is fundamentally a quadratic. I always want a 0. I like to have a 0, so I'm going to bring all of this stuff across to this side. I'm going to subtract a 9x on both sides, subtract a 13 to get a 0. So I'm going to get 2x squared minus 3x minus 9. Okay. Now, that now becomes a question which could come up a lot earlier in the exam. It's a calculator exam at this point, so if you wanted to, you could go and you could do this by using the quadratic formula. Usually in these questions, by just the elegance of it, it's probably going to factorize. You've got multiple ways of factorizing this. I'm going to factorize it using just inspection. You could do it by splitting the middle term. I'm going to get minus 3 plus 3. Nope, I'm going to do minus 3 plus 3. I know that works because 3x take away 6x is minus 3x. These multiply to give minus 9. If you're not happy with that little quick step there, do as much work as you need to get that thing there. So here I need to solve this. Let's move this up a little bit. So I have got two brackets, two pieces of maths multiplying together to give 0, so one of them must be 0. So either 2x plus 3 equals 0. Solving that linear equation, I'm going to get minus 3 over 2. Or I could have x minus 3 equals 0. And solving that, much easier, I get x is 3. So my two possible answers are x is minus 3 over 2 or x equals 3. You could go back and you could plug either one of those numbers in to check that when you evaluate this using one of those x values, you should get 2. When you evaluate this using the other x value separately, you should also get 2. Both of them work. So the steps in this are to get a common denominator and work through from there. Just to mention some other things you might have done. At this stage here, some people multiply straight away through by this common denominator and bring it across. At this point, you end up, whatever way you do this, with this line here. Okay, if you don't get this line here, something has gone wrong. So that's the end of this paper. Maybe some little bits are a bit too quick. If there's anything in this which has been raised as an issue, something you think you still don't understand, go speak to a maths teacher. If you find one of these topics you could sort of do, but maybe wasn't as secure as it could have been, go and practice more questions like that one there.